The next type of conic section we're going to take a look at is called an ellipse. So if you were to draw out a circle, in a circle, every point is the same distance from the center, right? You start at the center, you go left and right, you go up and down the same amount, and then you draw in your circle. And every point in the circle is the same distance from the center, right? That's the radius. Doesn't matter whether you're going left, right, or somewhere in between. That radius is always the same. But the question I asked was, what if the points in one direction were farther from the other? Well, then one axis would be longer than the other. You would get something that maybe you would call an oval or a running track, or it looks like an egg, something like that. Then in that case, what you have is not a circle, you have an ellipse. So the picture down here comes from, I think, the textbook, and it puts two pins in there. So suppose you put two pins on a board, right? Cork board, piece of wood, whatever, and you took a string and you stretched that string between those two pins, right? The string used to go directly between them, but you pulled them up and you're going to start tracing that string with the pencil. You notice that the distance here and the distance there always add up to the same thing. So the distance from one pin to your pencil plus the distance from the other pin to your pencil are always the same. If you're over here, then that's about the halfway mark. It looks like maybe these distances are the same. But if you were to move, very closely to the other side, then you might have a very small distance over here and then a much longer distance from here to there. But the sum of those distances remains the same as I move that pencil all the way around. So then eventually I would come around the other side and I would draw that pencil there. We have a name for those things. Each one of them is called the focus. That focus, no, not that focus. It's actually two foci. I guess foci is the plural of focus. So each of those points are a focus of the ellipse. Now you'll notice that the focus is not necessarily on the ellipse. In fact, for an ellipse, the focus will not be on the ellipse. However, each of these conic sections actually have foci. Circles have foci, parabolas have them, even though you've graphed parabolas for years and probably never knew that a focus was actually part of a parabola. It is. Ellipses have foci as well. Okay? No, not that kind of focus. Let's try to focus here. So, in an ellipse, there's a major axis and a minor axis, and it is exactly what you think it is. The major axis is the longer one. The minor axis is the smaller one. So I drew my ellipse over here going long ways. So the major axis is the one that goes top to bottom, so vertically. The minor axis goes horizontally. Doesn't have to work that way, right? You could have the major axis go left and right, and the smaller one go top and bottom. Where the two axes meet is called the center. Just like a circle has a center, an ellipse has a center. Technically, the vertices are only at the ends of the major axis. So one vertex is over here, another vertex is over there. Then there is endpoints of the minor axis as well, and so when we go to graph an ellipse, we usually can graph the endpoints of the minor axis also because it helps us to figure out just where to put this ellipse and how big to make it. Where are the foci on here? Well, maybe one of them is over here, maybe one of them is over there. Whatever they are, they're going to be symmetric about the center and the vertex. So in other words, whatever the distance is from here to the focus is going to be the same distance from the focus to the vertex on the bottom. And however far it is from the focus to the center over here will be from the focus to the center over there. So those distances are the same, and we can use that when we try to get information about our ellipse, either to write the equation or to graph it. When we set up the equation for an ellipse, when we did it for a circle, we had things like x squared plus y squared equals r squared. Well, when we do it for an ellipse, we're going to make that equation equal to 1. So technically, you can write the equation of a circle in the same way, right? If you divide everything by r squared, you would have x squared over r squared plus y squared over r squared equals 1. Well, over here, if you set it up with an ellipse, the a and b values are going to be different. And we'll take a look in a minute to figure out what the a and the b values are. Now, the textbook does all kinds of goofy things with different meanings for a and b. All I remember is take the square root of the a and the b. That tells you how far up and down to go in each of the directions. So we'll take a look at a couple of examples in a minute. But rather than memorize multiple versions of it, just use a little common sense as we go through. All right, so where are the foci? Well, the foci are on the same line as the major axis. Remember over here, the major axis was drawn, and I put the two foci, one of them over here, one of them over there. Well, the foci are always on the major axis. If the foci are on the x-axis, then they're going to be, let's say, here and here, same distance away, assuming that the center is 0, 0. If the center is not 0, 0, then we just count. If they're on the y-axis, then we look at places here and here. Where's the equation for the foci? It's down here. So when you come up with the foci, you have to subtract the two numbers on the bottom of that ellipse equation, but you have to do it in such a way that you get a number that's greater than 0. Meaning if you subtract like 20 minus 40, that's not going to work because you're going to end up with a negative value for c squared. So that's the only thing that I have to watch as I do this, that I'm subtracting in the correct order so that I don't get negatives under the radical, because I can't have imaginary foci in my ellipse. All right, let's try this. So the first one, x squared over 9, y squared over 36 equals 1. So take note on the top that this is not x minus 3 squared. It's not like a y minus 2 squared. It's essentially an x minus 0 squared and a y minus 0 squared. So because of that, we can right away say that the center is 0, 0. All right, so this is centered at the origin, and not surprisingly, the one underneath it is as well. All right, what's the square root of 9? Square root of 9 is 3. So that means since that 9 is underneath the x, start at the origin, go 3 units to the right, go 3 units to the left. 1, 2, 3. There's my other point. All right, what's the square root of 36? Square root of 36 is 6. That 36 is under the y. So in the y direction, I go 1, 2, 3, 4, 5, 6 units up. That's one vertex. 2, 3, 4, 5, 6 units down. That's the other vertex. This is my ellipse. Right, best I can on a tablet, I'm going to graph my ellipse. So this time the major axis is vertical, minor axis is horizontal. Right? Where are the foci? Well, for the foci, it says that c squared is the difference of a squared and b squared. So a squared and b squared are the two numbers in the bottom. So c squared, so c squared equals 36 minus 9. 36 minus 9 is 27. So c equals plus minus. I can simplify the square root of 27 by writing it as 3 square root of 3. So from the center, I'm going to go 3 square root of 3 units up. I'm going to go 3 square root of 3 units down. Now, in this case, the foci are pretty well up there, right? The square root of 25 is 5. This point up here is 0, 6. So the focus is between 5 and 6. So there's one focus. Focus number 1 is at 0, 3 square root of 3. The other focus is down here. Focus number 2 is at 0, negative 3 square root of 3. So if the vertical axis is your major axis, the foci are going to be located on that vertical axis, which is the y-axis. So we're going to go 3 square root of 3 units up. We're going to go 3 square root of 3 units down. And those are my two foci. All right, look at the second one. The second one is an x squared over 49, y squared over 4 equals 1. Well, for this one, square root of 49 is 7. Square root of 4 is 2. So I start at 0, 0, because again, this is x minus 0 squared, y minus 0 squared. And I count 1, 2, 3, 4, 5, 6, 7. So 7 in this direction, 4, 5, 6, 7 in that direction. And then 2 up and down. 2 up, 2 down. And I try to draw the best as I can a nice rounded off ellipse. It looks like a football, maybe. If we want the foci, c squared equals 49 minus 4. So c squared is 45. C is the square root of 45, which I can represent as square root of 9 square root of 5. So 3 square root of 5. Horizontal axis is my major axis. So the foci are at 3 square root of 5, 0, and negative 3 square root of 5, 0. Square root of 45 is very close to 7, right? Square root of 49 is 7, so square root of 45 might be here and there. It's going to be true in the case of an ellipse, that the farther apart these numbers are, the closer the focus is going to be to the very end of my ellipse. The closer together those numbers are, the closer the foci are going to be towards the center. They don't get right to the center, at least not unless you have a circle, but in terms of how close to the ends or the vertices they come, the farther apart those numbers are, the closer it'll be to one of the vertices. All right, this says graph label x and y intercept. So the first thing is I need this thing to be set equal to 1. So I'm going to divide both sides by 36. So divide this by 36, divide that by 36, divide that by 36. Well, here a 9 cancels top and bottom, and I get x squared over 4. Here a 4 cancels top and bottom, and I get y squared over 9. 36 over 36 is 1. So the square root of 4 is 2. We start at the origin. 2 to the right, 2 to the left. Square root of 9 is 3. 3 up, 3 down. All right, well, this looks a lot more circular than the last couple did, right? The last couple looked very oblong, especially that second one. This one looks more circular. Look at my c value. C squared equals 9 minus 4. So if c squared is 5, c is the square root of 5. Foci are going to be located on the major axis, so the vertical axis or the y-axis is the major axis. So I'm going to get 0 square root of 5 and 0 negative square root of 5, which I can write like this. Now the square root of 5 is just over 2. So here, those foci are a little bit closer to the center than they were before. Right? Square root of 5 is a little bit more than 2, so maybe down here. But still, they're much closer to the center relative to the size of the object than the previous ones were. So as those numbers get closer together, then those foci get closer to the center. All right, what if the center is not 0, 0? What if the center is some h and k? Well, then it works the same way that it worked for circles. X minus h squared, y minus k squared, except now we're dividing by those two different values that compose the distance from the center of the ellipse to the vertices or to the top-bottom piece on the minor axis. So let's match it up with this equation. X minus 3 squared, y plus 1 squared. You notice we've got 36s and 9s. Those are nice numbers. So the first thing is I need a center. Well, if it's x minus 3, the first coordinate is 3. If it's y plus 1, the second coordinate is negative 1. So that's where I'm going to start. 3, negative 1. Boom. All right, square root of 36 is 6. So I count 6 to the right. And I count 6 to the left. Well, there's 3 already. 4, 5, 6. All right, square root of 9 is 3. So from my center, I go up 3. And I go down 3. So here's an ellipse that's not centered at the origin. How do I find the foci? Well, start with that c squared equals the difference between the numbers on the bottom. So if c squared is 27, then that must mean c is the square root of 27, which is 3 root 3. Now, major axis is horizontal here. So if you want to find the coordinates for the foci, you've got to go from the center, 3 square root of 3 to the right, and from the center, 3 square root of 3 to the left. So the center, we said, was 3, negative 1. If I want to move left and right, that impacts that number over there. So my foci are going to be 3 plus 3 square root of 3, comma, negative 1, and 3 minus 3 square root of 3, negative 1. Now, you could combine these together by writing it as 3 plus or minus 3 square root of 3, right, and just write one ordered pair. So the square root of 27 is a little bit bigger than 5. So I count 5 and a little on one side. I count 5 and a little on the other side. Those are my two foci. Right? One of them over here, one of them over there. And so in this case, the foci were not on the x-axis or the y-axis. They were on the major axis of the ellipse, and that's going to be true always. All right, let's take a look at this one. Same idea as the last one. Center is going to be the opposites. So the center is going to be the opposite of 5, which is negative 5. Opposite of negative 3, which is positive 3. So go 5 to the left and go 3 up. There's my center. All right, the square root of 4 is 2. So in the x direction, I'm going to go 2 to the right. I'm going to go 2 to the left. In the y direction, I'm going to go 5 up and 5 down. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, there's my ellipse. This question says to find the length of the major and minor arc. Well, you notice that the square root of 25 is 5, right? So that must mean it's 5 units from the center to the top, but that also means it's 5 units from the center to the bottom. So you could just take the square root of 25 and double it. So the length of the major axis is 10. The same thing is going to be true the other way. If it's 2 units from the center left and center right, 2 plus 2 is 4. So the minor axis has a length of 4. All right, the vertices are these points on the top and bottom. So the x-coordinate is -5. The y-coordinate, well, if I went from -5, 3, and I went 5 up, -5, 8. And then what's the one on the bottom? Is -5, and then count down from here, 1, 2, 3, 4, 5, -2. And you notice the difference between 8 and -2 is 10, and that's what we said the length of our major axis was. All right, the last thing we have to do on this is to come up with the foci. So here we go. C squared equals 25 minus 4, which is 21. So C is the square root of 21. All right, what's the square root of 21? It's more than 4 and less than 5. Not a rational number. If I'm looking for the foci, where do I put the foci? They're going to be on the major axis, which is right over here, where the x-coordinate is -5. So for my foci, the x-coordinate is -5. The y-coordinate starts at 3 and then goes up and down by the square root of 21. So up here and down here. So it goes from 3 up and down the square root of 21. So those are my two foci written together as an x-coordinate and a y-coordinate. You could separate them, right? You could do -5, 3 plus the radical, -5, 3 minus the radical, and you'll have your two individual foci. All right, we'll do a third video with completing the square and the application stuff.